So in today's video we will talk about interfacial angle and laws of crystallography. This interfacial angle. In a crystal, angle between normal of the two adjacent faces is called interfacial angle. Suppose this is a crystal. Draw normal on this face and normal on this face. So angle between this normal of two adjacent faces will be interfacial angle. This will be some angle A. This is 90 degree. This is also 90 degree. So sum of all this will be 60 degree. So IA plus A 360 minus 180 degree. So interfacial angle will be 180 degree minus A. It can be measured with the help of a contact goniometer and reflecting goniometer. We move towards laws of crystallography. Law of constancy of interfacial angle. Interfacial angle of a crystal of a particular mineral always remains constant regardless of the shape and size, providing that chemical composition temperature doesn't change. So if a particular mineral has different types of crystals, suppose it is crystal 1, this is crystal 2. Draw normal. So interfacial angle in both of these two crystals of a particular mineral will be constant regardless of the shape and size. But there should be a condition that chemical composition and temperature doesn't change. Second law, law of rational indices. First we have to some intercepts. Intercepts are parameters. What are parameters or intercepts? These are the points where crystal face cuts the crystallographic axis. Suppose we have a one standard face A B ABC and second face DEF. A B C D E and F. So here parameters of DEF with respect to the standard face ABC are 1 by 1, 2 by 1, 1 by 2. Here we can see in all the axes, you can compare with standard face. In A axis both cut at 1 units. At B axis here the face DEF cuts at 2 units, and at C axis the ABC cuts at 2 units, which is greater than this. So we can draw relation between them. OD will be equal to OA, OA will be equal to twice of OB, and OF will be half of OC. So parameters of D, E, F with respect to the standard face ABC are 1, 2 and half. And we will do reciprocal of these parameters, which are known as indices. So now it will become 1, half and 2. So this law states that according to crystallographic notation by Miller, a law has been establishing stating that the intercepts that any plane makes on the crystallographic axis are either infinite or small rational multiples of intercepts made by unit plane. Intercepts made by any plane on the crystallographic axis, they can be infinite or rational multiples of intercepts made by the unit plane. And the ratio between the intercepts of two plane can be expressed as 1 ratio 1, 1 ratio 2, or 1 ratio any rational number, not like 1 ratio root 2 or any irrational number. Now next law is the law of axial ratio. Ratio between the lengths of the crystallographic axis of the crystal of a given substance or mineral is constant, i.e. axial ratio is constant. Crystals of a particular mineral lengths of the crystallographic axis of crystals of a particular mineral and their ratio will be constant. For example, in cubic system we have A1 axis, A2 axis and A3 axis. So all the crystals of the cubic system will have this same ratio, 1 ratio 1 ratio 1. All the crystallographic axis of all the crystals of the, which belong to the cubic system will have this same ratio. Law of crystallographic axis. Crystals of a given mineral can be referred to same set of crystallographic axis. For example, galena may be referred to three set of crystallographic axes which are equal in length and mutually perpendicular and interconvertible. Different crystals of galena are referred to three set of crystallographic axes that are equal in length and mutually perpendicular, and their all the properties can be explained with all this three set of crystallographic axes only. And final law is the law of constancy of symmetry. Symmetry in all crystals of a particular mineral species is constant, though they may not be similar in form. It means the symmetry elements in all types of crystals of a particular mineral will be constant, but it is not necessary that they might be similar in form. Example, all crystals of galena, whether cubic, octahedral shape, show same symmetry elements: 9 plane of symmetry, 13 axis of symmetry, and 1 center of symmetry. So that's in today's video. Thank you.